Hello! Today we are doing rate of change for Algebra 2, Chapter 2, Section 3. I don't want to get confused because Algebra 1 is in the same section, obviously different textbook, but this is Algebra 2. So rate of change, and I'm pretty confident that should say and slope, and I just noticed that. I'm so sorry. Oh well. Anywho, so rate of change is basically the change in y or the change in x, and oftentimes you will see it symbolized with this little delta symbol. Which just means small change, so change in y, change in x. And we have an example to kind of show you how this is going to work out. It says the table shows, and I have a table right here, the table shows the temperature of a solution after it has been removed from a heat source. Find the rate of change in temperature for the solution. So we have 5 points to choose from here. And where'd my book go? Ah, I think someone stole it. Excuse me. It's okay. I don't really need it, but I just looked over and it wasn't there and I got a little freaked out. Sorry. Anywho, so you can pick any 2 points that you'd like to start with. So since Jonathan's in here, we might as well give him a shot at this. Which point would you like to use, sir?
I don't know.
Gee, thanks. Okay, so it doesn't matter, but let's just go ahead and pick like this point and maybe this point. It doesn't matter. You could pick 0 and 12 or 2 and 5 or 0 and 2 or 8 and 12, whatever, but you pick 2. So I'm going to pick those little guys. So the change in y means that we're going to take the difference in the y values. So I'm going to go with the 139.4 and I'm going to subtract 126.8, and that is my change in the y variable. And then I have to do the same thing for the x variable, but you have to keep in mind that once I put 139.4 first, then I have to put the 2 first. You can't like be all mixy-matchy. So now it's got to be 2 minus 8. Okay, so again, just to be clear, this is my, my second y value, my first y value, my second y value, so I have to make this my first x value. I can't change it now. But it doesn't really matter which direction you go in as long as you're consistent. So, because my brain is not fully functioning right now, which is kind of scary for you, I'm not even going to attempt to subtract those in my head. It's 139.4, and we're going to subtract 126.0, and we get 12.6. It's not 13, it's 12.6.
Oh, I didn't see 8.
2 minus 8 is negative 6. So our answer is going to be negative, which means that the temperature is probably, or the rate of change is actually decreasing, it's going down, which would make sense. 12.6 divided by negative 6 gives us a whopping negative 2.1. So this tells us that the temperature is dropping 2.1 degrees every minute, just in case they didn't really ask us to interpret the slope or the rate of change, but there you go. It is dropping or decreasing by 2.1 degrees Celsius every minute. So that is example 1, and we are going to give you a shot at doing one yourself, and there is the graph for you. And again, if you don't like my graph, it's too hard to read, you can also find it on page 76 of your textbook. All right. So now we're going to go to example 2. This is do it yourself, the materials don't go there. We're going to go to example 2. Bam! Look at that. Isn't that cool? I stole this picture out of your book and I copied it into my board. It's really cool how I can do that. Because it was like a really crazy graph and I didn't want to have to draw all that. And then you would just yell at me and tell me that it was ugly. And so here it's all pretty. And then because this is all black, I can like write in like crazy like glow-in-the-dark ink. It's kind of cool. So anyway, here's example 2. It says, find the average rate of change of the percent of total music sales for both CDs and downloads from the years 2001 to 2008, and then it asks us to compare the rates. So here's 2001 right here, and 2008 is right there. And this graph right here, if you can't see it right here, it's downloads, and this graph represents CDs, so you can say downloads, CDs. Okay, so we're going to find the rate of change 2 times, and then we're going to compare our results. So over here in green, yay, glow in the dark, we get to take, first I'm gonna go with the CDs. Yeah, CDs. So with the CDs, we know that in 2001, this is 2001 right here, the value right here is 89.296. 89.296. That is the percent of sales for CDs in 2001. And then we know that in 2008, we had CD sales 77.8%. And you know what? I already read that. This is 89.2%. That's not a 96, it's a percent symbol. 89.2, so my bad. 89.2. There we go. So to find the rate of change is very simple. We're going to take this Y value, it doesn't really matter which one, but again, stay consistent, 89.2, and subtract 77.8, and I'm going to divide that by 2001 minus 2008. And again, we go to my trusty little calculator, he's so cool. 89.2 minus 77.8 is 11.4. And 2001 minus 2008 is -7. So we're going to get 11.4 divided by -7 is -1.6. So again, because it's negative, that means that our sales in CDs is decreasing by 1.6% each year. So that's the CDs. Remember, they wanted us to find it for CDs and for downloads. And for downloads, we're going to have to come over here into the graph because I don't have space over there. But for downloads in 2001, we have that the amount of download was 0.2%, 0.2%. And then in the year 2008, the percentage was 12.8% downloads, 12.8. So we're going to calculate the rate of change here. So again, we're going to just start with this Y first. So it's 0.2 minus 12.8. And then divide that by 2001. Remember, please stay consistent. So 0.2 minus 12.8 is -12.6. Don't laugh at me. I can already see John Miller laughing at me. Doesn't she know how to subtract? Not really. -7. So negative divided by negative is a positive. So 12.6 divided by 7 is 1.8. So even though we have smaller percentages for downloads, we can see that it's, in this case, a positive value means that it's increasing by 1.8% per year. And the CDs are decreasing because, hello, nobody buys CDs anymore. We're all moving to the technology craze, and that's download, download, download. So anyway, that is example 2. And now we get to go back to the regular board. And now you can do this here, do it yourself, number 2. And I told you wouldn't have enough time to write it all down. Okay, so now we go to slope. And basically, slope is the formalization, if you will, of rate of change, okay, on a coordinate plane. So earlier, we weren't really necessarily having to look at a graph. We just had information that we were using to find the rate of change. But now we're going to formally assign it to an actual coordinate plane situation. And so what I have over here is an XY axis with a random blue line. There's not really any scale, but I've gone ahead and I've labeled 2 separate points, X1, Y1, because this is the X1 coordinate, the Y1 coordinate. Then we've got X2, Y2. This is the X2 coordinate, the Y2 coordinate. And we know that the slope or the rate of change is the change in Y over the change in X. So you can see that right here I kind of marked off that this is the change in Y. And change in Y literally means difference. When you go to the store and you buy something and they say, what's my change? You basically subtract. If you bought an item that cost $15 and you gave them a $20 bill, I hope they were going to give you your change back. And I hope that you would know that it was $5 and they wouldn't cheat you of your money. But anyway, change means subtract. So all it really means is when you say change in Y is the difference in the Y values. So you can see over here in the formula you've got Y2 minus Y1 subtraction because that's how you find change. And then we have the same thing for the X values. the change in the x values is also subtracted. So you take the larger x value minus the smaller x value, and you have this little guy, a slope. So given that a line passes through points x1, y1, and x2, y2, so you're going to give you these 2 points, then we can always very simply calculate the slope or the rate of change of the equation. So this is our formula, and we have an example here. Find the slope of the line that passes through, and it gives us 2 points. One of the first things you want to do is to make sure that you label your points. Okay, so that's always pretty important. X1, Y1, remember I told you earlier, the same is true here. You have to be consistent. I can call this point X2, Y2 if I want, and I can call this one X1, Y1 if I want. But I cannot call it X1, Y2 or X2, Y1. You have to be consistent. Once you've chosen the first point, then they both have to be 1s or they both have to be 2s. You can't do one of each. So aside from that, you just plug into your formula. So we know that after we've labeled, that means that my slope will be y2, according to my labeling, is 5. And y1, according to my labeling, is 3. Divide that by x2, which is 2. And then be careful when you have negatives because the formula is a subtraction. So that's obviously 2 minus. But then when you subtract a negative, it actually becomes a plus. So it's 2 minus negative. And I like to do that where I put minus negative and make it into a plus because a minus negative is always going to be a positive. And then I'm going to get 5 minus 3 is 2, and 2 plus 4 is 6. And you get 1/3 as your slope or rate of change. All right? So now you are going to try these little puppies right here. Do it yourself number 3. And then we're going to go to this guy. I think this is our last example. Let me just double check that before I miss. Yep, that's our last example. And these, I wanted to make sure I did one of these because this is pretty much the exact same thing we just did. But sometimes students find it hard to extract the ordered pairs from the graph. So the difference between this and the first example, the previous example, was that I told you what the 2 points were. And when you look at this next example, I'm not telling you what the points are. You have to find them. And so I'm just going to say to you that don't try to pick a point that is like in between the lines. You want to make sure, I mean, obviously my graph doesn't have a grid, but your graphs in the book will have, grids like this. Don't try to pick a point that's like right here. You want to try to find a point that is actually on a nice little crosshatch. Those will be the best points to use. It's not always possible, but it's generally possible to do that because you want to make sure that you get the right point values, because if you don't, then the whole problem is going to be off, not because you don't know how to do it, but because you have the wrong numbers. So the first thing we have to do is extract points. And so I'm looking at my graph, and this point right here looks like a pretty good one. And it happens to be x negative 2, and obviously the x always goes first. So x negative 2 and the y coordinate 0. And the other point that I think looks pretty good is right here. And the x coordinate for that point is 0. And the y coordinate being negative 3. So now that I have those 2 points, the rest of it is pretty much the same. We're going to label x1, y1, x2, y2. And then we're going to calculate our slope. The formula, if you don't remember, was y2, which is negative 3 in this case, minus y1, which is 0, divided by x2, which is 0, and minus negative 2. So again, minus negative is a plus. And I'm just going to warn you, a lot of students make that mistake of not making those pluses, and then they get the wrong answer. So negative 3 minus 0 is negative 3, 0 plus 2 is 2, and our slope is negative 3/2. And I didn't mention it earlier, but you probably remember from before that the letter that we use for slope is M. I'm not really sure why, because slope starts with an S, but that is the letter that we use for slope. So now that you've done that, you can do this little do-it-yourself question, and once you have done that, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching. And